Welcome to my projectbazaar.com. Let us discuss about the ultra wideband antenna for brain stroke and brain tumor detection. Let us discuss about the abstract of the product. So the microstrip antennas basically consist of radiating patch on one side of dielectric substrate which has a ground plane on the other side. So the patch is generally made of conducting material such as a copper and gold. So the patch is very thin. So the different radiating patches may be square, rectangle, thin strip, circular, elliptical, triangle, or any other configurations. So the radiating element and feed lines are usually photo etched on dielectric substrate. A microstrip patch antenna is also a low profile antenna. It has a number of advantages over than other antennas. So microstrip like a patch antenna must be easily to achieve also. So in this proposed work, to design the UWB pentagon shape antenna to detect the brain tumor and brain stroke. So here using UWB means ultra wideband. So that is a UWB antenna. So in this patch antenna operating at also a UWB frequency, right, a wide range of frequency, right, 3 to 12 GHz. That is a range between the UWB antenna. So the dielectric substrate here we using the FR4 substrate. So FR4 is a one type of substrate material here we using. That is also simple and easy also. So the dielectric constant is 4.4 and the dimension of the substrate is 44 cross 30. The height of the substrate is 1.5 mm. So all the dimension is particularly defined by mm only. So this antenna is useful to find the brain stroke and brain tumor on the normal human head, whatever it may be, easily to find out in the particular brain person it's a stroke or tumor like that. So this will be designed by using the HFSS software, and finally we analyze the radiation pattern, directivity, return loss, VSWR and bandwidth of the proposed antenna are calculated by using the hands-on HFSS software package. So HFSS here we using the high frequency structure simulator, that is called a HFSS. All the design must be implemented in the HFSS software. Let us discuss about the flow diagram for HFSS, that is a high frequency structure simulator. So the HFSS design is like a 3D X, Y and Z axis. So first of all open the HFSS software and create a new project design. So whatever it may be we design, so create a new project design and then substrate model. So here we assumption here we using the FR4 substrate, so that is a dielectric constant is 4.4, and also select the patch model like rectangle, circle or another model. So select the patch type model to design the top and bottom of the patch. So here we using the design and top patch is patch antenna and the bottom is ground plane. So assign the boundaries for perfect T, that is a perfect electric field for the top and bottom patch. So top patch here we using the patch antenna, so perfect T is assumption the top, and bottom here we using ground plane, so perfect T is assumption. And then excitation, here we using the excitation as waveport analysis for the particular for feeding portion, so like a coaxial probe like that feed. And then to set up the analysis like start and stop frequencies and also the center frequency of the process. So for example 3 to 12 GHz means, so that is a 3 to 12 GHz of the process. So assign the frequencies means in between the frequency like 6 GHz like the process. To assign the vacuum boundary of radiation, so in this box we assign the radiation of the patch antenna like to prevent the environment from the process. So finally get the results like return loss, radiation pattern, VSWR, bandwidth, and also in 2 dimension and 3 dimension also. So here we using the structures. So this is a design of pentagon shape antenna. So this is a pentagon shape like it should be like forwarded in the HFSS software, and this is a partially ground. So that is not a fully ground, this is a partially ground. So these are the dimension and length in mm. So L1 is 44 like that. So this pentagon shape antenna is usually easily to product the software of the process. So overall it must be easily to detect. This is side view representation and layers of the antenna. So this is a patch and a microstrip feed. So and this is on the ground plane. So in between the patch and ground, here we using the substrate. So the substrate is FR4. Here we using the substrate of the process. So overall this is a side view representation of the process. And then finally calculating the finally get results like radiation pattern, return loss. Radiation pattern always must be in a 2D and 3D also. In return loss always we must calculating minus 10 dB below, so only we calculating easily define us. And then VSWR radiation pattern like 2D and 3 dimension also. For example, here we using the pentagon shape antenna by using the HFSS software of the process. So these are the important design to whatever it may be, the length is must. So and also substrate. So these are the overall running of them, and then also the overall flow diagram of the process. Yeah, now let us discuss about the running procedure for the process. So this is the HFSS window. In the HFSS window, here we using assumption of pentagon design. So this is like a pentagon design, and then the flow of this is patch and then substrate and then ground plane of the process. So in the boundaries here we using a perfect T1 for perfect T1 for the electric field, and perfect T for ground plane, and then perfect E3 for the partial ground plane of the process. And then radiation pattern here we assumption of the 3D radiation pattern of the particular process. So here we using the radiation pattern like whatever it may be, the value will be calculated. So that is the process of pentagon design of the process. So in this process the patch model is to be described. So in the patch model, so yeah, here we assumption as a FR4 substrate. So FR4 substrate only we use, so that is a FR4 substrate, and then perfect T, that is a pentagon design of the patch antenna, and then whatever it may be, we only design for that. So these are the two dimension of the values, and these are the 3 dimension of the particular values. So in the excitation process, here we assumption of the waveport analysis. So here this is a radiation pattern, so assigns the radiation excitation of the process, and then analysis setup. So in this analysis setup 1, so solution frequency is 8 GHz, and then the number of passes is 20, and then maximum value which should be getted in the value, and then sweep. So in the sweep process, the start and stop frequency 2 GHz, and then stop frequency is 14 GHz of the process, and then linear setup, so whatever we will be calculating of the process. So finally we calculating the, so these are the validation checkbox. So all the values which we check: design settings, 3D model, boundaries and excitation, measure and analysis setup, optometrics and radiation. So all the values which will be getting, and then finally getting the results. So this one is a return loss like that. So this is the, and then this is the validation checkbox, and then this is analysis setup. So it takes some time to running the procedure. So all the values which we data, and then finally calculating the return loss, and then radiation pattern of all the parameters it should be display of the process. So and then calculating the results of the antenna. So in this process return loss will be calculated. So the return loss is minus 10 dB of the process, and then finally calculating the VSWR of the value. So the VSWR is must be below 2 minus dB of the value. So and then the radiation pattern. So in the radiation pattern we calculating the gain of the value. So the gain of the process must be calculating the 360 degree of the process, and also it must be calculating by using the minus and then 6 gigahertz of the value. So it's like a 2D pattern of the particular HFSS design, and then this is the 3D. So in this 3D the red value should be high intensity of the process. So here we assumption x, y, z for I, pi, theta and gamma of the value of the process, and here the same assumption for the stroke design. So in the stroke design, here we assumption the this is the antenna of the process. This antenna is placement of the top of the process, and then the brain tumor, it should be assumption in the ball. So that's the ball is a tumor. So here is the sphere is a tumor, and this is the skull, and this is the skin of the process, and then FR4 substrate will be used. The tumor will be calculated by using the value. So whatever it may be the calculation, the value which must be calculated. So the rectangle process, top of the design should be calculated, and then tumor and sphere. So the sphere is calculated. So whatever it may be, the value should be calculated. So these are the overall running procedure for the process. Thank you for listening this video.